Droplet digital PCR, or ddPCR, is a method for performing digital PCR that is based on water-oil emulsion droplet technology. A sample is fractionated into 20,000 droplets, and PCR amplification of the template molecules occur in each individual droplet. ddPCR technology uses reagents and workflows similar to those used for the most standard Tachman probe-based assays. The massive sampling partitioning is a key aspect of the ddPCR technique. Today's section provides an overview of droplet digital PCR technology, how ddPCR works, and what the advantages and benefits of ddPCR are. What is droplet digital PCR? The droplet digital PCR system partitions nucleic acid samples into thousands of nanoliter-sized droplets, and PCR amplification is carried out within each droplet. This technique has a smaller sample requirement than other commercially available digital PCR systems, reducing cost and preserving precious samples. ddPCR technology uses a combination of microfluidics and proprietary surfactant chemistries to divide PCR samples into water in oil droplets. The droplets support PCR amplification of the template molecules. They contain and use reagents and workflows similar to those used for the standard Tachman probe-based assays. Following PCR, each droplet is analyzed or read to determine the fraction of PCR-positive droplets in the original sample. The data is then analyzed using Poisson statistics to determine the target DNA template concentration in the original sample. Bio-Rad's QX200 droplet digital PCR or ddPCR system consists of two instruments, the QX200 droplet generator and the QX200 droplet reader, plus their associated software and consumables. The QX200 droplet generator partitions samples 20 microliters into 20,000 nanoliter-sized droplets for PCR amplification. Following amplification using a thermocycler, droplets from each sample are analyzed individually on the QX200 droplet reader, where PCR positive and PCR negative droplets are counted to provide absolute quantification of target DNA in digital form. Step 1 is droplet generation. Prior to droplet generation, nucleic acid samples, DNA or RNA, are prepared as they are for any real-time assay, using primers, fluorescent probes, Tachman probes with FAM and hex or VIC, and a proprietary supermix developed specifically for droplet generation. Samples are then placed into the QX200 droplet generator, which utilizes proprietary reagents and microfluidics to partition the samples into 20,000 nanoliter-sized droplets. The droplets created by the QX200 droplet generator are uniform in size and volume. Step 2 is PCR amplification of the droplets. Droplets are transferred to a 96-well plate for PCR amplification in any compatible thermal cycler. Step 3 is droplet reading. Following PCR amplification of the nucleic acid targets in the droplets, the samples are placed in the QX200 droplet reader, which analyzes each droplet individually using a two-color detection system, set to detect FAM and either hex or VIC, enabling multiplexed analysis for different targets in the same sample. The droplet reader and its bundled Quantisoft software count the PCR positive and PCR negative droplets. Digital droplet reading. Fluorescence measurements for each droplet in two optical channels are used to count the numbers of positive and negative droplets per sample. Step 4 is analyze results. Positive droplets containing at least one copy of the target exhibit increased fluorescence over negative droplets. In ddPCR, the Quantisoft software measures the number of droplets that are positive and negative for each fluorophore, for example, FAM and hex in a sample. The fraction of positive droplets is then fitted into a Poisson distribution to determine the absolute initial copy number of the target DNA molecule in the input reaction mixture in units of copies per microliter. Sample results from a ddPCR experiment. Each droplet in a sample is plotted on a graph of fluorescence intensity versus droplet number. All positive droplets, those above the threshold intensity indicated by the red line, are scored as positive, and each is assigned a value of 1. All negative droplets below the threshold are scored as negative, and each is assigned a value of 0. This counting technique provides a digital signal from which to calculate the starting target DNA concentration by a statistical analysis of the numbers of positive and negative droplets in a given sample. The benefits of droplet digital PCR. ddPCR technology enables high-throughput digital PCR in a manner that uses low sample and reagent volumes and reduces overall cost compared with other methods while maintaining the sensitivity and precision that are hallmarks of digital PCR. The benefits of ddPCR technology include absolute quantification. ddPCR technology provides an absolute count of target DNA copies per input sample without the need for running standard curves, making this technique ideal for measurements of target DNA, viral load analysis, and microbial quantification. Unparalleled precision. The massive sample partitioning afforded by ddPCR enables the reliable measurement of small fold differences in target DNA sequence copy numbers among samples. Increased signal-to-noise ratio. High copy templates and background are diluted, effectively enriching template concentration in target-positive partitions, allowing for the sensitive detection of rare targets and enabling a plus or minus 10% precision in quantification. Removal of PCR bias. Error rates are reduced by removing the amplification efficiency reliance of qPCR, enabling the detection of small 1.2-fold differences. Simplified quantification. Neither calibration curves nor a reference to the delta-delta CQ method is required for absolute quantification. Reduced consumable costs. Reaction volumes are in the pico to nanoliter ranges, reducing reagent use and the sample quantity required for each data point. Lower equipment costs. The emulsion-based reaction system means that the PCR reactions can be performed in a standard thermal cycler without complex chips or microfluidics. Superior partitioning. ddPCR technology yields 20,000 droplets per 20 microliter sample, nearly 2 million partitioned PCR reactions in a 96-well plate, whereas chip-based digital PCR systems produce only hundreds or thousands of partitions. The greater number of partitions yields higher accuracy. Thanks for watching.